My bad, beautiful friends. I seem to have forgotten this example, so I'm going to do this one and show you a flow proof because I don't think I did that very well in the last exercise. All right, so check this out. Here we are with example 3, and we're going to find angle measures in right triangles. So we're just basically going to find the information about each of these angles. And sometimes geometry is just better when it's bigger. So basically we got to find the angle measures for everything. So let's see. Sometimes I like to start off by writing what I know. And what I know is that this is 90 degrees. And what I know is that this here is 90 degrees. And so with that given information, that doesn't look like 90. With that given information, is there anything that I can figure out? Know that this is 90 and this is 90. I get that this is 90 and this is 90, but we're going to use this later because this being 90 doesn't give me 3 or angle 3 or angle 2. You with me? All right, so let's go ahead and think about it. So if I know that this is 90 right here, then I can find 1 by adding 52 plus 90 and adding something else that's going to give me 180. So let's do that. So looking at this triangle here, we get this relationship here. When I add all of this together, I get 142 plus the measure of angle 1 is equal to 180. And clearly, if I subtract 142 on both sides, I get that we are dealing with a 38-degree angle here. So that's helpful. I'm going to write 38 degrees here. 38 degrees. And so now that I know that this is 38 and this is 90 and this is 52, what else do I have? Well, I can come over here and find out the measure of angle 2. And as I took the moment to write this down, I realized that I'm kind of using the same numbers here. Like if 52 plus 90 plus 38 equals 180, then 38 plus 90 plus 52 has to equal 180. So I kind of just like was, wait a minute, this has to be 52. And if we do the math, you'll see that, right? If I added 38 plus 90, you guys get where I'm going with this, right? I get that 120, what is that, 128, and then I subtract that, and then I'm going to get 52. And so I'll get that the measure of angle 2 is 52. And if that's the case, well, 52 plus what gives me 90? Oh, that's got to be 38. And if that's 90, this is 90 here because this is 90 and this is 52. Did you see how I did that? I mean, I could have added it together, but if I add this together, I'm going to get 52. They said that both of these angles are together would give me 90. So angle 2 plus angle 3 has to be 90. 52 plus what is 90? 52 plus 38. And then if that's 38, then I know that this angle here is 90 because this is a straight line, and this is 90 and that's 90 because 90 plus 90 is 180. So then I got a 90, 38, and what must this angle be? It must be 52. That was kind of fun. All right, so now that we've looked at this example, I hope that this makes the assignments easier, and I'm going to take a look at a flow proof for you. Okay, so I pulled this directly from your textbook, and I did ask you guys to read it in the first section, in the first part of this video. But here's some information. This is the exterior angle proof. Remember, we were talking about if you pull an exterior angle, you get the fact that it's equal to the 2 remote interior angles. And I tried to say, oh, see, you remember. Anyway, so here's what a flow proof looks like. So we'll start off with the given. All we're given is that this triangle, this thing ABC is a triangle, and that the measure of angle A plus, and so we're trying to prove that the measure of angle A plus the measure of angle B is equal to the measure of angle 1, this exterior angle. So here's the deal. We start off, a flow proof starts off with information, and then underneath it, it's the justification. Information, triangle, justification. And then if you see that to justify eventually that these two angles are equivalent, the sum of these two angles would be equal to this one angle, we go through by first exploring the idea that the 3 angles of the triangle add up to 180. We're given that by the triangle sum theorem. Then what they're talking about over here is, okay, so on the one side we're talking about these 3 angles adding up to 180, and on this side we're going to talk about these 2 angles adding up to 180. So we're first define them as a linear pair, then we know that linear pairs are supplementary, then we can say that the definition of supplementary is that these 2 guys are adding together to give you 180. So if you notice, the flow proof now comes to a part where you're like, yeah, this fact and this fact are the 2 facts I'm about to put together to then make my claim. So let's see how they did that. They took the idea that all of this added together is 180 and all of this added together is 180, and then they did a little bit of substitution. So let me see where it was. A plus B plus 2 is equal to the measure. Okay, so the measure of angle A plus B plus angle 2 is the same as the measure of angle 2 plus angle 1, because we know that they're both equal to 180, right? So they substituted that in there. Then the next step was to say, well, I think subtraction, what they have to do. Yeah, they'd have to subtract away the same thing on both sides. Remember, subtraction property of equality. You can take away things that are equal on both sides of an equation. This is stuff that we do all the time in algebra, and then you get this, which was the thing we were trying to prove. All right, so that's the example of a flow proof. If you read through it and you just, did it on your own, great job. If not, I'm glad we were able to do it together. All right, take care, guys. Let me know if you have any questions. Bye bye.